Yo, what up guys? So in today's video what I want to do is talk about and take you through networking, what's the purpose of it, why is it important, and how to do it. So basically networking, and we're not talking about social networking, we're talking about computer networking, which means basically making, basically a network is made by two or more devices connected together. That makes a network. And why do we network? Well, because if you think about it, it's much easier to administer networks. If you have one, for example, if you have 50 computers in a network, it's easier to administer if you have them connected together, and therefore you can, for example, say, okay, these 30 computers are going to get an update, and these 30 computers are going to stay active, and then we're going to swap. Or what you can do is, for example, you can obviously, well, if you would not have a network, if you wanted to, for example, you were doing IAT support and someone would need their password changed, you would have to manually go to that computer and change it. And instead of doing that, you can just go to the server administrator, right? Program and just change the password, and there you go. That just saves a lot of time. Plus, it's also security. If you were actually not to network these computers together, the internet would most likely, it'll be about, basically it's not a good practice, right? Because then a firewall is a hardware firewall is basically the traffic is going through the firewall. In the future videos I'm going to explain how firewalls work and stuff, not today. You don't need to know what firewalls are and stuff for today. Basically, why is it, basically the traffic is going through the firewall and then into the network and all the way back, so through the network to the firewall and then to the internet. And obviously if they're not networked together, then you can't really, get them to be going through the firewall, if you know what I mean. I'll try to give you a picture on the internet. I'll show you how it works. Okay, so I'm just going to make a network, a small network right now, and explain stuff and how to set IP addresses, how IP addresses are calculated, what is an IP address, and why do we need an IP address. So basically, we need a PC. Let's get two computers, right? Two computers. We're gonna get a server because I like doing servers, and we're gonna get a switch, 29060. Okay, so what we're going to do now is take this bolt, and by the way, I'm using Cisco Packet Tracer, and somewhere on the screen I'm gonna link how to get Cisco Packet Tracer. Make sure to install it. It's a very, very good program because you can do certain things you can't do in real life. For example, I don't have 15 devices. I don't have a switch and servers. Server is manageable. You can just get any device, install server on it, and that's a server domain controller. And a switches are basically anywhere from 1,000 to about like £5,000. And as you may think, I don't have £5,000 just to throw away on a switch. And I would love to. Maybe if I was in professional employment, I could show you guys how to make this stuff, but not currently. Possibly next year I'll be going into professional employment, and then therefore I could possibly do this stuff. So you need to survive, and I need to show you this way. Is there a chance I can zoom in? Yes. There we go. That's better. Okay, so what we need to do now is take this automatic connection type, because you obviously, if you're watching this video, most likely you don't know which cables goes to which. So basically I cannot remember exactly. I would have to go back to my notes, but I'm pretty sure copper crossover goes to normal devices like the same type, and copper straight through goes to any devices that are from a different, for example, if you were to connect a printer and a PC, you would use two different cables. The reason I cannot remember why, I think it's not to cause any complications between the devices. I cannot remember, sorry guys. So just plug it in. We use fast Ethernet. Sorry, I just used automatic. So just use automatic. But if you're going to plug in, you make sure you plug into fast Ethernet, not USB or RS-232 or anything like that. Make sure you use. And for this, you can use. I suggest using fast Ethernet. I think gigabit internet would work, but I think it has some problems. I'm not sure. I usually just do fast Ethernet and usually the last ports. Obviously, because we're not doing this professional network, we can just put on whatever you want. I usually put on the last two past, because why not? So basically just plug it in, and the switch. Remember that. Now I'm going to explain this stuff. Why did I do this? Why not just direct to the server? So basically, we have a small network right now, and this will, as you can see, this is just going to take a second to recognize. And switches, by the way, this is a switch, this is a server, this is a PC. The reason I'm explaining this, because it's important that you can recognize this stuff, because if you ever do IT support or cybersecurity, you use Cisco packet tracer regardless. Okay, so as you can see, we have devices connected now. Why did I connect the PC to the switch? Well, because if you disconnect it, the server has only one port, which means you cannot connect a computer to the server. I mean, you can, but it's only technically beneficial if you have one computer in a network, right? So if we wanted to, example, connect another network, what we have to do is connect this other switch to this switch or another switch and then to the server, because only server has one port, right? Server, as I said, is just a computer, so usually you have like 1-2 ports, right? So, what did I want to say? So basically this is a switch. That is why we use the switch to the server. And as I said, if you want to connect, for example, if I was to have another server, or another network, for example, sorry, we have this, and what you would do is get another switch. Actually, I don't need a switch in it, because this network's too small. So just connect this to this, and there we go. We have 2 networks now. Now, technically this is the same network. It matters what IP address you put. But what I mean by this is if you want to expand your network, you need to use this switch or another switches to connect. You cannot just directly connect the computer to the server, right? And in a second, I'm going to explain IP addressing. We're going to assign IP addresses, and in the later video, I possibly will show you how to get connect 2 different IP addresses, which means 2 different networks together, right? Because routers, we use routers for that. Routers, the basic router you think you go at home is a bit different. It's an actual switch you have at home. Routers have a certain different purpose. Routers are used to connect 2 different networks together, as I said. So if you have, for example, an IP address of 100 and you were to connect another IP address of 150 to 200, right? I know it doesn't make sense what I just said, but in a second you'll understand more. So basically we have 2 different, we have the same network basically, with a couple of devices on it. So what I'm going to do now, I'm going to assign an IP address, and on the screen right now should be a picture of IP class addressing and what this means, and I'll try to explain it as best as I can, and it's not going to take you a second to understand this, because networking is not something you can understand after 1 second. It will take you a couple of seconds. In my networking class, there's people that are having big problems, and for the level I'm doing and they're doing is not very good, that they don't even understand the basics of networking. It's not their fault, it's basically how the education center sort of allowed them into the course without previous networking experience. It's also not their excuse, because if you're ever going to do cybersecurity, you need to be prepared to fucking have anything that's thrown at you. You need to be prepared for this, right? So what we're going to do now is, I've showed before how to assign IP addresses. I'm going to show you again, because this is obviously a tutorial. So basically go to PC, desktop, and IP configuration. Now you cannot use, and make sure you use IPv4 IP, not IPv6. Do not use DHCP because it's not going to work. However, I can show you how to set it up. Actually, I'm going to show you using DHCP because it's going to show you a bit how IP addresses are being dished out. So you go to server, you go to services, you go to DHCP, turn this on, turn DNS on. DHCP, and then you can change the pool name. I just leave a server pool, right? It's default gateway. For this example, I'm going to use class C address, which starts with 192. As I said, in a second, you should get a picture of IP addressing tables, and I'm going to explain each IP address, what's the difference between them. So 192.168.11. For an IP address, we're going to use, default gateway, we're going to use 1. DNS server, we're going to use the same IP address. Now, the starting IP address, we're going to use 10. Now, the reason is I'm skipping so far ahead from the IP addressing is because Usually the first 10 IP addresses, at least from my experience and my teacher's experience, they reserve the 10 first, like 10, 15 IP addresses for devices. For example, switches, routers. Actually, routers don't have. Sorry, routers are having the default gateway IP address. Just basically any device, right? Subnet mask 255, 255, 255. I know you don't understand what the fuck I'm talking about, but as I said, in a second, I'm just going to show you. So we have the IP address turned on. Make sure you service the service on and DNS turned on. As soon as you've done this, basically, what you need to do now is just go to PC, IP configuration, DHCP, and you should get a good message that says DHCP has been... Oh, sorry. Now, the reason it's not going to work because I've not set IP address for the server. The server itself needs an IP address. So for this, we're going to use 192.168.11.2. Or 0.2 is fine. Okay, so now if you go back to the PC, IP configuration, you change it back. It should, as you can see, it says 192.168.11.10. And subnet mask of this and default gateway this and this. This is all correct, as you can see, because this is the domain controller. Domain controller, as I say, domain controller is the network administrator for the specific network. He's the brains of the operations. That's why in some networks you have two servers, because if obviously one computer goes down, your whole network fails, because then if you were to connect a computer, you can't get an IP address, you can't send data. There's nothing you can do without a domain controller. That's why usually you have two servers. Now, obviously, we cannot do the same thing for this server. We can set IP addresses for the switches. I'm not going to do this now because it's not really important for you to know how to do this. Now, we cannot set the same IP addresses as you saw a second ago. We cannot set the same IP addresses for the computers. Why? Because every device needs a different IP address. You cannot have the same IP address for the same device. The reason is because this would cause complications, plus it would talk to two devices at the same time. And you cannot have that. You need an individual IP address for every device. So, as you can see, every device has its own IP address. Now, as I said, you cannot set the DHCP for this server as well. The reason, because you cannot have two domain controllers at the same time. You need one domain controller and one backup. If the server goes down, the server knows itself that, okay, I'm the domain controller now, right? They switch, they rotate over. You don't really know which one's in control currently. You can check, obviously, but you don't really need to know this as long as they work, right? Sorry. So I'm going to explain, let me just get actually a screenshot of the IP classes. I'm going to show you stuff, how to calculate them and stuff like that, right? The E is experimental and D is multicast. Class A and class B and C, right? Now, if you check the IP address, now it doesn't actually show you. I'm going to get another picture in a second. I just want to explain this first. Actually, I'm going to get another picture. Right, so as you can see, we have a byte 2, byte 3, byte 4, byte 1 to 4. IP addresses have an IP, they're in binary, which means they're in 8 bits per 1 octet. Right, so altogether, if you do 8 times 4, it's 32 bits in an IP address. That means we need an IP address of 32 bits. Right, if you ever do binary, you sort of have an idea what I'm talking about. Basically, the IP address needs to be 4 octets. 4 octets, I'll show you here. An octet is this, the first 3, not the whole, obviously the whole sequence, but the one, this is an octet, this is an octet, this is an octet, and this is an octet. Every single digit divided by a dot and basically between is an octet, right? Don't worry about the subnet mask. I'm going to explain this in a second. You really do need to know those subnet mask. You just need to know it's a part of the IP address. You won't really modify the subnet mask unless you get to subnetting, but I'm not going to show you subnetting. A bit more complicated if you're talking about it. Okay, so as you can see, I've got another picture. I know I'm using someone else's pictures here. Well, sorry, I'm not a very graphical student, which means I don't want to draw because my drawings are below toddler's level. I cannot draw, right? I'm a programmer, but not a fucking... I'm trying to get this fit because we don't need to use these. We don't really use these. Right, so we don't need to really know this. I will just leave it. I was going to take out. So the first octet of the binary, what would happen is between this range, for example, if you were to have an IP address of, for example, 10.10.10.10 is a class A address, right? If you were to have an IP address of 151.151.151.51, which means it's a class B address. Class C, example, IP address I just set on my Cisco packet tracer 192.168.11.39 is a class C address. Now, if you ever have an IP address, you only need to know the three first digits or the first digit between the octet. So for example, if I was to set, I will show you here, for example, I was to set an IP address of, this is class C because it's between the range, as you can see, as long as it's between this range, including the range, because as you can see, it's different. If it's 1 to 8, it's class B. If it's 1 to 7, it's class A. Class C is 192. Right, that's the thing to remember this. Okay, so now why do we split these IP? Why do we have these IP classes? Why do we not just have like the same one class? The reason is because every network has its own different subnet mask, which is the part of the IP address, as you can see here. I showed you before. And the hosts. Now, this is basically the amount of hosts or client or end devices you can have on the network. Class A is the biggest one. There's millions, as you can see, there's millions of devices you can put on there. Millions, right? You can put fuck knows how much you want. Now, so basically on one network, for example, class C address, on one network, you can only have 254 usable IP addresses. Why? Because 256, there's actually 256 altogether, but only usable for devices, there's 254. The reason, because the first IP address, 01 or 1, is reserved for default gateway or the network address. 255 is something we call broadcast address. Broadcast address is used for broadcasting to anyone in the network. So if you want to ping, for example, I want to check if everyone in my network is replying to me, or you want to check how many devices you have on your network, what you can do is use 255 at the end. So if you were to ping, I'll try and show you right now, actually, it should be very, very easy to show. So let's go for the server, command prompt ping 192.255, and now, as you can see, I'm getting a reply. As you can, also by the way, ping is something used, it's a multicast ping, pretty sure it's called, when you just ping from one device to another. Sorry, unicast, not multicast, unicast, sorry. Or I'm getting mixed up because, yeah, I'm getting mixed up now. So basically what you do is you just put the broadcast address. As you can see, I'm getting a reply from every single device on my network 3 times. Now, in Linux, if you were to do this, you would get a constant reply. If you were to do this on a Windows, as you can see, you can set it to specific. I can set it to 10. This should work if I'm not wrong. And this will send me the ping 10 times. As you can see too. Free. Now let's just leave this, I don't need to fucking watch this, right? And the maximum is 1 millisecond. That's very, very, very quick. If you were to send a file, it will be very, very quick across the network. Now, so as you can see, obviously, as the class of the IP address goes, as the higher the IP class, the smaller the subnet mask. So as you can see, class A 255.0.0.0, class B 255.255.0.0, class C 255.255.255.0. And that's what you would do. Example, I'll show you right now in Cisco packet tracer. If you go back to IP configuration, there's subnet mask, and it starts with whatever I have here. And because, as I said, this is a class C address, 255.255.255.0. If it was to be an IP address of 10.10.10.10, it will be 255.0.0.0.0. It will be 255 and 3 zeros, right? It makes sense. I know you'll be possibly struggling right now. That's why I suggest just going over what I'm talking about and trying to solve this yourself, and also use packet tracer. You will never get good at networking if you just watch videos, right? What you need to do is get practice. I'm good at networking. The reason is because I know I've been practicing a lot and I've been around IP addresses for some time now, right? I've been doing IP addressing for, a longer time now. So I didn't just sit in front of a computer and say, okay, teach me, right? I said, okay, you teach me the basics. I understand the theory, the basics. And now I'm going to do, I was launching, as soon as I got home from college, even on like lunch breaks and stuff, I was launching Packet Tracer and I was doing this. The reason is because I like doing this. Like, this is my networking is something I like doing, right? And because there's usually a lot of problems with networking because sometimes that you need to okay, what we need to do here? It's problem solving, right? And I love problem solving. Like if I'm determined to do something, I will fucking get it done no matter what. I'll get it done. Okay, so hopefully you sort of understood what I'm talking about. I know I'll have to possibly go back and explain stuff back again. I'm just telling you sort of the basics you need to know. I'm just going to close this for now. Show you how to calculate IP addresses. Now, IP addresses are calculated in binary, as I said before. So what we're going to do now, I'll try my best to draw this. So what we're going to do is 128, or maybe I could get a binary table, 2 seconds. Right, so I managed to get a binary table. This will make everything easier. So basically binaries are only calculated in zeros and ones, right? So if anybody asks you, how do you calculate an IP address? For example, can you make me an IP address of 200? Now, this is basics maths. You can obviously use a calculator if you want. I don't know how good you are with maths. I am good, but not good. No, I'm joking. I'm pretty good, but it's just, yeah. So basically, don't want to embarrass myself. So basically, 128 would be 1, 1, 8, and 0, 0, 0, 0, and 0. This makes a binary 8-bit. This is 8 bits, by the way, because obviously 1, 2, 3, 4, 5, as you can see, there's 8 boxes, 8 bits, right? 16 bits would be all the way to, I think it's 256, like something like that, right? Whatever it is. You just basically, every time you got binaries to the power of 2, right? You double it. So 1, 2, 3, 4, 8, 16, 64, 128, and you go 256, 512, 1024, whatever it is next, 1048, whatever, 4096. And you keep going till you get to 65,000, whatever. So this is, as you can see, 128, 64, and 8 is 200, right? So let's just put 200. And you will be already around binary if you ever done computer science, because computer science is the first thing they usually teach you is binary, I think. I can't remember. I don't know. Let's make it 192. So for example, if I was to make it 192, it would be like 164 0 0 0 0 0 0. And that's how we calculate IP addresses. And that's how we calculate IP addresses. So as you 110000000192. Now you don't really exactly need to know this because obviously the computer calculates itself how to do binary, right? The computer only operates on zeros and ones. It's binary all the time. You don't know it's binary because obviously we don't understand binary, right? There's millions of binary sequences, whatever. As soon as you hit your keyboard, it sends a pulse to the computer and it comes out as binary. It's not actually like K, we press K. The computers know it's K because it has done a binary calculation. That's what processor does for you. That's why you cannot turn on your computer if you don't have a processor, because there's nothing to process your data. Your operating won't start, your operating system won't start with a processor, right? It's the whole brains of the operation. It's like an engine. If you don't have an engine, you're not fucking going anywhere, are you? Right? That's the same thing with computers. So that's how you calculate binary. It should be very, very easy. There's nothing complicated about this, right? So I'm gonna leave this. And to be honest, I think that's it for like the first video. I'm gonna split this networking tutorials into a couple parts. In the second video, I'm most likely gonna explain how to do, like, what's the purpose of switches and stuff like that and how they operate. I can tell you right now that switches are a layer 2 device and they operate on MAC addresses. They have MAC address tables and they operate on MAC addresses, which makes it a bit faster than IP addressing. And also, if you not have an IP address, I'm pretty sure they're able to send data without them, which makes them good. So hopefully you've enjoyed this tutorial. Make sure to check out the other tutorial, which I'll make in the future. I'm probably obviously not going to make it now because I need to make good notes and stuff and also prepare myself. I don't want to teach you guys shit. That's not the purpose. As I said before, the purpose of my video, of my YouTube, is to make an easier and more detailed understanding of things. That's why my videos are sort of, I talk more, but the reason is because I give you guys more detail and I try to explain. I don't try to rush things. I want to give you guys as much stuff as fast as I can, but also, you know, I just switched jobs. Also, I have went back to college. I've been a bit busy past 2 weeks. That's why I've not been able to upload anything. This is my actual first day that I've been able to have, okay, I can just sit down and do this for whenever I need to, how much time I've got left. Okay, so hope you've enjoyed. If you can leave a like, subscribe, comment. Plus, I've also made a Discord server, which will be in the comment section. And also,